Dear students, in the last class we discussed standard jet transforms and few signals like infinite duration from 0 to infinity or minus infinity to minus 1, infinite duration signals and corresponding ROC we calculated. And a short video is prepared to calculate finite duration signals. That is the second model. For finite duration signals, what are the ROCs is presented in the last class. In today's class, few special problems we will discuss. These are very, very important along with that previous also. Right. So before starting that, once again, you need to recall that what are the standard Fourier transforms, sorry, standard jet transforms. A power n, u of n, jet transform will be z by z minus a, where mod z is greater than a. A power n, u of minus n minus 1. Here, there is a confusion, sir. Sometimes you told minus, sometimes you are telling plus. That is, both are same only, right? So z transform is z by z minus a, mod z is less than a. Sir, if I am writing a power n, u of minus n minus 1. So what is the z transform? This minus will come this side, that's all. Minus z by z minus a, where mod z is less than a. So don't confuse between these two, both are same. Just here, minus a power n, u of minus n minus 1, z transform will be z by z minus a, where mod z, this is very important. ROC is very important. If you consider from here, you just substitute a is equals to 1. What we will get? U of n z transform will be, u of n z transform will be z by z minus 1. What is the corresponding ROC? Mod z should be greater than 1. Now here, u of minus n minus 1 z transform is z minus z by z minus 1. So here a is considered as 1. So from here. Now what is the corresponding ROC? Mod z is less than 1. And already I told any impulse signal, if you consider in any transformation, del of n, z transform will be 1. These things you need to remember. Now along with this, we will discuss some important problems. Like first problem, x of n is equals to u of minus n. And second one, I will list out the problems so that whenever if you want to refer, it is easy to recall from here. X of n is equals to a power minus n u of minus n, a power minus n u of minus n. A power minus n, u of minus n. Third one is x of n is equals to a power minus n, u of minus n minus 1. Fourth one, x of n is equals to minus a whole power n, u of minus n. Fifth one, x of n is equals to a power modulus n, where a is less than 1. And sixth one, x of n is equals to cos omega naught n into u of n, cos omega naught n into u of n. Seventh one, x of n is equals to sin omega naught n into u of n. So now in today's class, we will discuss all these 7 problems so that we can complete basic jet transforms. So in the next class, we will see the properties anyway. So now I will solve that one by one problem. First one is x of n is u of minus n. X of n is equals to u of minus n. So before going to this problem, I want to tell you one thing. Modulus n. What is my modulus n? Modulus is nothing but n is nothing but n for n is greater than 0 and 0 for, sorry, minus n for n is less than 0. This is greater than or equal to 0. That means modulus n, whenever you saw the modulus n, you can write it as u of n, sorry, modulus n is nothing but n for u of n. U of n is nothing but 0 to infinity. That is the meaning n is greater than or equal to 0. So minus n is nothing but u of minus n minus 1. What is the limits? Minus infinity to minus 1. But what is minus n limits? N limits are 0 to infinity. What is minus n limits? Minus infinity to 0. These two you need to differentiate. Many students, they are getting confusion between modulus n and minus n. The limits, basically the limits we are getting confused. Okay, now x of n equal to u of minus n. So now we know that x of n z transform is x of z. What is x of z? X of z equal to summation n equal to minus infinity to infinity x of n z power minus n. What is x of n? U of minus n summation n equal to minus infinity to infinity u of minus n z power minus n. What is this u of minus n? U of n is there, the limits will be 0 to infinity. U of minus n is there, the limits will be minus infinity to 0. So now here summation n equal to minus infinity to 0 z power minus n. Now here, but we know the formula, that is here summation n equal to 0 to infinity alpha power n is 1 by 1 minus alpha, where alpha mod alpha is less than 1. This is the formula. We know that mod alpha is less than 1. Mod alpha modulus alpha less than 1. So this is the formula we know. In the previous problems also we used this. So but here the limits are from minus infinity to 0, right? So what I will do here, n is equals to, let n is equals to minus m. So now what will happen? This will become m is equals to infinity to 0. This will become m equal to infinity to 0. Summation n is equals to infinity to 0 z power m. Remember one thing, we are using the summation. Summation m is equals to 0 to 3. Summation m equal to 3 to 0, both are same. X of n is there, for example. If you consider these, both are same because you are summing the values x of 0, x of 1, x of 2, x of 3. Here x of 3, x of 2, x of 1, x of 0, both are values are same. So that's what, for our understanding, I will write this one as summation m is equals to, here m is equals to 0 to infinity z power m. What is the formula here? N equal to 0 to infinity alpha power n. What is the formula? 1 by 1 minus alpha. Here I will get 1 by 1 minus z power m. That is, this is the alpha, right? Now what is the z value? Mod z should be less than 1. Mod z should be less than 1. So this is also one more important problem in the z transform. If you want to extend like this also, you can write m equal to 0, that is 1, m equal to 1 z, m equal to 2 z square, plus and so on. So it is in a GP, right, geometric progression. The sum of the infinite series will be 1 by 1 minus z, right? So this is the first one solution. Coming to the second problem, x of n is equals to a power minus n u of minus n. So now here I will take the second one. X of n is equals to a power minus n u of minus n. Same thing we need to write here. X of n z transform is x of z, where x of z is equals to summation n equal to minus infinity to infinity x of n z power minus n. Now, what is summation n equal to minus infinity to infinity x of n will become summation n equal to minus infinity to infinity. What is x of n? A power minus n u of minus n z power minus n. So again you see that u of minus n is given. So what will be the limits? Otherwise you can write it as u of minus n is there, means u of minus n, u of minus n equal to 1 for n is less than or equal to 0, otherwise. Simple. If you want to write, you can write like this. Otherwise, what is the u of minus n limits? U of n minus limit will become minus infinity to 0. Simply you can write like this. Here summation n is equals to, here u of minus n is there, limits will become n equal to minus infinity to 0 a power minus n z power minus n. Again here also you see that minus is there, right? So that's what, okay, here on I will write as summation n equal to, here I will take it as n equal to minus m, n equal to, let n is equals to minus m. Then what is the x of z will become, x of z is summation m equal to infinity to 0 a power m z power m. So if I rewrite that expression, x of z is equals to summation n equal to 0 to infinity a into z whole power m. What is the formula we recall? Summation n equal to 0 to infinity alpha power n is equals to 1 by 1 minus alpha, 1 by 1 minus alpha. What is the ROC? Mod alpha should be less than 1. Okay, mod alpha is less than 1. From this one, mod alpha is less than 1. So from here, I will write this one as 1 by 1 minus, what is the alpha here? Az. So Az modulus should be less than 1. I want z. If you send that a that side, it will become, anyway, your x of z will be 1 by 1 minus Az. Mod z less than a, send that side, it will become 1 by a. Mod z less than 1 by a. Remember, whatever the problem they given, first of all, you write that what is the z transform. Not only z transform, in the Fourier transform also, you write that whether it is a continuous Fourier transform or discrete time Fourier transform, first you write that set of expressions. You remember that, and you write in the first line itself what is the Fourier transform, what is the z transform. Like that if you write, it is very easy to substitute the xn values. Now we will see the third problem. Third one, x of n is equals to a power minus n u of minus n minus 1. See here. Now, what is the u of n limits? What is the u of n limits? 0 to infinity. What is u of minus n limits? Minus infinity to 0. U of minus n minus 1 limits? Minus infinity to minus 1. So, you try to understand this. Now, what is x of n z transform? X of n z transform is x of z. What is x of z? X of z is equals to summation n equal to minus infinity to infinity x of n z power minus n. What is x of n? You substitute, you write it here. Summation n equal to minus infinity to infinity a power minus n u of minus n minus 1 into z power minus n. Sum is equals to summation n equal to minus infinity to infinity, minus infinity to infinity. What is the u of minus n limits? u of minus n minus 1 limit minus infinity to minus 1. Here n equal to minus infinity to minus 1, a power minus n z power minus n. Now you substitute here, let n is equals to minus m. Let n equal to minus m or minus n equal to m, you can take it. Now what is the your x of z will become? X of z is equals to summation m equal to infinity to 1 or 1 to infinity, you can write a power m z power m. So now I will write it here, x of z is equals to summation m equal to 1 to infinity a power m a into z whole power m. I will write it here, a z whole power m. Here if I want to substitute the formula, what is the formula? Summation n equal to 0 to infinity alpha power n. What is the z? What is this formula? Is equals to 1 by 1 minus alpha, where alpha should be less than 1, mod alpha should be less than 1. If I want to use this one, what is the n ranging? What is the n range? 0 to infinity. But what is the m range here? 1 to infinity. That's what I will do here. Summation m equal to 1 to infinity a z whole power m plus 1 minus 1 I will do. Plus 1, what I am doing here? Summation. Otherwise, if you consider here a z whole power 0, what is that? 1. So that's what m equal to 0 I am substituting, so you will get 1. So that's what combinedly these two terms I will write it as summation m equal to 0 to infinity a z whole power m minus 1, because I am adding this one into this summation. That's what you will get, a z whole power m minus 1. So what is this expansion? 1 by 1 minus a z minus 1. So what is that? ROC. ROC is mod a z less than 1. Now your x of z will become, you take the LCM as 1 minus a z, what we will get? 1 minus 1 plus a z. You can write it as az divided by divided by 1 minus az. So you can write like this. Otherwise you just take a is common, what we will get? Z divided by z minus 1 by a. You can write it as z by z minus 1 by a. Here minus z by z minus 1 by a. What is the ROC will become? Mod z is less than 1 by a. You just a, I will write it here somewhere. Here I will write az divided by 1 minus az is equals to, I will write az divided by minus az minus 1. Here I am just minus multiplying. 1 minus az will become az minus 1. Now a you take common, az divided by, if you take a common, z minus 1 by a. So a cancel, what you will get? Z by z minus 1 by a. Like this, just I am directly writing minus z. Here it is, minus is there. Here also you will get minus z by z minus 1 by a. So like this, we need to solve this one. This is the third one. Next, what is this fourth one? Fourth one is minus a whole power n u of minus n. So now fourth one, x of n is equals to minus a whole power n u of minus n. If you practice more problems, then it will be easy to remember in the examination also. So what is that? Z transform x of n, Z transform will be x of z. What is x of z? Summation n equal to minus infinity to infinity x of n z power minus n. You substitute the values. Summation n equal to minus infinity to infinity. X of n is minus a whole power n into u of minus n z power minus n. Again, I will write the limits here. U of n limits are 0 to infinity. U of minus n limits are minus infinity to 0. So now my u of minus n is there. I will write it here. Summation n equal to minus infinity to infinity. So I will write the limits is summation n equal to minus infinity to 0 minus a whole power n into z power minus n. Same thing, n equal to minus n you substitute. N equal to, let n equal to minus m. So what is your x of z will become? X of z is equals to summation m equal to infinity to 0 minus a whole power n equal to minus m z power m. Now x of z is equals to summation m is equals to, I already told, if you write infinity to 0 or 0 to infinity, it is a summer, no? So that's why both are same. M equal to 0 to infinity minus a whole power minus 1. Minus a whole power minus 1 into z whole power m. Minus a whole power minus 1. What does it mean? Summation m equal to 0 to infinity. What is my a power minus 1? That is 1 by a. So now minus z by a whole power m. A power minus 1 is there, no? That's what 1 by a. Minus a whole power minus 1 means 1 by minus a. You can write minus z by a. Now it is similar form like summation n equal to 0 to infinity alpha power n is 1 by 1 minus alpha mod alpha is less than 1. So by using this formula, everywhere you need to write whatever the formulas you are using, you write at particular problem. X of z is equals to 1 by 1 minus z by a, where minus z by a less than 1. Minus z by a less than 1. Now, you will get 1 by minus into minus plus 1 plus z by a 1 by 1 plus z by a comma modulus of minus z by a will become z by a only. Z by a less than 1. So now you just take LCM as a and it will become a by a plus z, or we can say z plus a. You can write a plus z or z plus a. Mod z is less than a. So this is the x of z for the given signal. For the given signal. Now we will see next problem, fifth problem. X of n is equals to a power modulus of n, where a is less than 1. So now here modulus is there. Already I told, whenever you will have the modulus, you need to write very carefully. What is x of n will become? X of n will become a power n u of n plus a power minus n. You write here modulus n is nothing but n for n greater than or equal to 0 minus n for less than 0. So a minus a power minus n u of minus n minus 1. Here we need to be careful. So now what is the Z transform of a? Apply Z transform. Here apply Z transform. What is x of n Z transform? X of z equal to a power n by u of n. What is the Z transform? Z by z minus a minus a power minus n by a power minus n is there. So this a power minus n, I will write it as, okay, before doing only, I will write it here, because we need to remember the formulas. What are the two formulas we standard signals? A power n, a power n, u of n, z transform is z by z minus a, where mod z is less than, sorry, mod z is greater than a. Is a right sided signal, mod z is greater than a. Now a power n, u of minus n minus 1. What is the z transform? Z by minus z by z minus a, mod z is less than a. Now see here, a power n u of n you can write directly, but a power minus n is there. These type of problems very you need to be very careful. A power minus n is there. How can I write this? 1 by a whole power n I can write like this, right? A power minus n is nothing but 1 by a whole power n. So now I will rewrite this. X of n is equals to a power n u of n plus 1 by a whole power n. Whenever, for example, 3 power minus n is there, you carefully write 1 by 3 whole power n. Like this, you need to be careful. 1 by a whole power n, u of minus n minus 1. What is the Z transform now? Apply Z transform. What is x of n Z transform? X of z equal to z by z minus a minus z by z minus 1 by a. Now, if you want to take the LCM and if you want to simplify, we can do that. Simplification, simplification we can do, but ROC, what is the ROC for this? Mod Z is greater than A, mod Z is greater than A, intersection, what is the ROC for this? Mod Z less than 1 by A, because it is left-sided signal. Now, so this is the corresponding ROC for the given problem. Right? Now, next one. So now, before going to the sixth problem, I will add one more question here, because, okay, here I will consider sixth one is x of n is equals to exponential term. If I will consider here e power j omega naught n into u of n. So this will be seventh one. This will be our eighth problem. Okay, so sixth one is x of n equal to e power j omega naught n into u of n. So now x of n is equals to e power j omega naught into n into u of n. You can write omega like this, or omega naught, you can write e power j omega naught n. Okay, the notation is I will write as per VTU. I am writing a power j omega naught n into u of n. Here also I will modify e power minus j omega naught e power j omega naught n. This is also omega naught n. So here also omega naught n, sin omega naught n. Now here x of n equal to e power j omega naught n u of n. So we need to write that, find the Z transform and ROC. That is the question they will give. So directly you need to write x of n Z transform is x of z. What is x of z? Summation n equal to minus infinity to infinity. What is x of n? X of n z power minus n. Now summation n equal to minus infinity to infinity. What is x of n? E power j omega naught n into u of n z power minus n. Now see here, u of n is there. What will be the limits? Limits will become n equal to 0 to infinity, n equal to 0 to infinity, e power j omega naught n z power minus n. Now n you take outside, I mean in terms of power, n equal to 0 to infinity e power j omega naught z power minus 1 whole power n. Now again you rewrite the formula summation n equal to 0 to infinity alpha power n is 1 by 1 minus alpha mod alpha is less than 1. So by using this formula, what is your x of z? X of z is equals to, here we need to write the ROC. Till now ROC is not required from here, because whenever you are using this formula ROC we need to write that, you remember. X of z equal to 1 by 1 minus, what is the alpha? E power j omega naught into z power minus 1. What is that ROC? E power j omega naught z power minus 1 modulus should be less than 1. So now 1 by 1 minus e power j omega naught z power minus 1 is nothing but 1 by z. Here also e power j omega naught into 1 by z modulus less than 1. Now you just take LCM z and it will go to the numerator. Z by z minus e power j omega naught. This will become mod z is greater than e power j omega naught. Z you send that side, it will go to, okay, I will write here e power j omega naught less than z, less than z. That means mod z is greater than e power j omega naught. Right. So this is the e power j omega naught into n. So now don't confuse between Fourier transform and Z transform, because in Fourier transform e power j omega naught means there is shift. So here don't confuse. You just follow the formula, whatever the notations and the formula you just follow. Now the next problem is seventh one. X of n is equals to cos omega naught n into u of n, omega naught n into u of n. So whenever you saw the sine term or cosine term, we need to represent exponential form 1 by 2. What is the exponential form? E power j omega naught n plus e power minus j omega naught n whole into u of n. So this is the x of n. Now you can split here. If we will split here, then it will be easy. 1 by 2 e power j omega naught n into u of n plus 1 by 2 e power minus j omega naught n into u of n. So now x of n z transform is x of z. What is this x of z? X of z is equals to summation n equal to minus infinity to infinity x of n z power minus n. Summation n equal to minus infinity to infinity. What is this x of n? 1 by 2 e power j omega naught n u of n plus 1 by 2 e power minus j omega naught n u of n whole into z power minus n. Now I'll split the terms here. Summation n equal to minus infinity to infinity 1 by 2. I will take outside. E power j omega naught n u of n z power minus n plus 1 by 2 summation n equal to minus infinity to infinity e power minus j omega naught n u of n z power minus n. Now you remember there is a u of n term is there. So what will be the limits? Limit will be 0 to infinity 1 by 2 summation n equal to 0 to infinity e power j omega naught n into z power minus n plus 1 by 2 summation n equal to 0 to infinity e power minus j omega naught n z power minus n. Now 1 by 2 summation n equal to 0 to infinity, we just take e power j omega naught into z power minus 1 whole power n plus 1 by 2 summation n equal to 0 to infinity e to the power of minus j omega z power minus n whole to the power of n, sorry, z power minus 1. This is z power minus 1 whole power n. Now, by using the formula, that is summation n equal to 0 to infinity alpha power n is 1 by 1 minus alpha, where mod alpha is less than 1. If you use this one, what we will get? 1 by 2 1 by 1 minus e power j omega naught into z power minus 1 plus 1 by 2 here 1 by 1 minus what is alpha value? E power minus j omega into z power minus 1. So now the z power minus 1 will go to the numerator. That means z by, okay, 1 by 2 into z by z minus e power j omega naught. We just take 1 by 2 common here, no problem. Then take common plus z by z minus e power minus j omega naught. So this is the z transform. Again, we need to simplify this. How we will simplify? By taking the LCM. I will take one more page. So z by, so what is x of z we got? X of z is equals to 1 by 2 z by z minus e power j omega plus z divided by z minus e power minus j omega naught. Right? Now, we just take the LCM 1 by 2, take LCM z minus e power j omega into z minus e power minus j omega naught. So it will go to the numerator. Z also you can take outside. This will become z. Is out z by 2. This will become z by 2 in the outside. Here only I will take better, so it is easy for you to understand. This is 1 and here it is 1 because I am taking the z is outside. Now this will go this side, z minus e power minus j omega naught plus z minus e power j omega naught. Now we can simplify this one as z by 2 into 2z minus take common e power j omega naught plus e power minus j omega naught divided by z into z square, multiply with each term z into e power j omega naught. So it will become minus z times e power j omega naught plus e power minus j omega naught plus e power j omega naught into e power minus j omega naught value is 1. So now what is e power j omega plus e power minus j omega will be e power j omega naught plus e power minus j omega naught will become 2 cos omega naught. 2 cos omega naught. So now I will substitute here z by 2 into 2z minus 2 cos omega naught divided by z square minus, again here also 2z, so 2 cos omega naught, right? 2z cos omega naught plus 1. What is the ROC for this? What is the ROC? E power j omega, I will write it here, e power j omega naught z power minus 1, right? ROC is e power j omega naught into z power minus 1. It should be less than 1. What is that? One more, e power minus j omega z power minus 1. e power minus j omega naught z power minus 1 less than 1. So it will become mod z is greater than e power j omega naught intersection. This will become mod z greater than e power minus j omega naught. So this is the resultant ROC we will get. It is greater than e power j omega naught and e power minus j omega naught. So simple. What is the here? What is the magnitude for this? Magnitude is 1. What is the magnitude of e power j omega? E power j omega magnitude will become 1. So now here also this thing also not required. Directly you can write it here. Directly you can write it here. Z inverse less than 1 and Z inverse less than 1. So that means mod Z is greater than 1, mod Z is greater than 1. So what is the resultant ROC? Directly you can write mod Z is greater than 1. So this is the resultant ROC for this. Now we will see that 8th question, x of n is equals to sine omega naught n into u of n. So this one also, again you expand this in terms of exponential form. What we will get 1 by 2j times e power j omega naught n minus e power minus j omega naught n. Now you just substitute in this x of n 1 by 2j times e power j omega naught n minus e power minus j omega naught n into u of n. So what is the x of n z transform? X of n z transform is x of z. What is x of z? Summation n equal to minus infinity to infinity x of n z power minus n. So now here I will write x of n value here. Summation n equal to minus infinity to infinity 1 by 2j e power j omega naught e power j omega naught minus e power minus j omega naught n into u of n z power minus n. Now u of n is there. What will be the limits? Limits will be 0 to infinity. So x of z is equals to 1 by 2j. You can take outside common summation n equal to 0 to infinity e power j omega naught n minus e power minus j omega naught n into z power minus n. Again split this 1 by 2j times 1 by 2j summation n equal to 0 to infinity e power j omega naught n z power minus n minus e power minus j omega naught n z power minus n. So now same way, if you do that, if you simplify that, you just do on your own. What is your x of z will become? X of z will become z into sine omega naught. Okay, I'll solve that. So now this will become 1 by 2j. So n equal to 0 to infinity summation n equal to 0 to infinity e power j omega naught into z power minus 1 whole power n minus summation n equal to 0 to infinity e power minus j omega naught into z power minus 1 whole power n. Now 1 by 2j times, if you expand this 1 by 1 minus e power j omega naught into z power minus 1 minus same thing here also we will get 1 by 1 minus e power minus j omega naught into z power minus 1. So 1 by 2j, this will become z by z minus e power j omega naught minus z by z minus e power minus j omega naught. You just take z common, that means you take this z outside. So what is your x of z will become? Your x of z will become z by 2j, z by 2j, 1 by z minus e power minus j omega, 1 by z minus e power j omega naught minus 1 by z minus e power minus j omega naught. Now z by 2j, take LCM, z minus e power j omega naught into z minus e power minus j omega naught. If I consider, you will get in the numerator z minus e power minus j omega naught minus z plus e power j omega naught. So z minus z, it will become, both are cancelled. We will get z by 2j, z by 2j e power j omega naught minus e power minus j omega naught in the numerator divided by what will be in the denominator? Z square minus z into e power j omega naught plus e power minus j omega naught plus 1. So your Z transform will be Z by 2j times, this will become 2 sine omega naught, 2 sine omega naught divided by Z square minus Z into, this will become 2 cos omega naught, 2 cos omega naught plus 1. So now what is the final R, final x of z? X of z equal to, you can take 2, you can get cancelled. I think in the previous problem also we can cancel it, right? So 1 second. Here also you can cancel it. So here I will write the final answer, x of z equal to z into z minus cos omega naught divided by z square minus 2z cos omega naught plus 1. So now here also I will write the final answer, x of z is equals to z into sine omega naught divided by z square minus 2z cos omega naught plus 1. So now what is the ROC? ROC is same. ROC is mod z is greater than 1. Mod z is greater than 1. So these are the few problems regarding the Z transform. And in the next class, we will see that properties of the Z transform. So please watch the video and prepare for the examination. I will update the videos regularly.